So in this video, we're going to do a numerical example of a first price common value auction. So let's suppose again that there are two people bidding on the good. Ti is a signal that is generated for each of them, and for each of them, for I equals 1 and 2, Ti is generated from a uniform distribution between 0 and 100. Vi, which is person i's valuation, is equal to Ti plus Tj divided by 2. Show that Bi, which is the bid for player I, is equal to 3 divided by 4 Ti. That bid function is a Nash equilibrium. Now how do we show that? Well, first we suppose that player 2 plays B2 equals 3 by 4 T2. So just suppose that player 2 follows this bid function. Then, if player 1 also follows this bid function as a best response to player 2 following that bid function, we would have a Nash equilibrium. Then we will have shown that this is a Nash equilibrium. So how do we do it? First we need the probability that player 1 wins playing B1 when player 2 is choosing a bid B2 equals 3 divided by 4 T2. The likelihood that player 1 would win playing B1 is the same as the likelihood that T2 is less than 4 divided by 3B1. And given that T2 is generated from a uniform distribution between 0 and 100, that likelihood is equal to 4 divided by 300 times B1. The expected value of T2, given that P1 wins, will be 2 divided by 3B1. The reason for that is we know that T2 lies between 0 and 4 by 3 B1 if B1 wins, and therefore if B1 wins, the expected value of T2 will be exactly halfway, so at 2 divided by 3 B1. The expected payoff for P1 for player 1 therefore becomes T1 plus B1 divided by 3, which is basically Ti plus Tj by 2, just substituting in T2 here, minus B1, which is the amount that player 1 would have to pay, times 4 divided by 3 B1, which is the likelihood that player 1 would win. The first order condition just maximizes this, so I've just multiplied inside this parenthesis, this bracket, by B1. I'm ignoring the 4 divided by 300 because that's just a positive number and I can ignore it when I'm maximizing this function. You can put that in there, but it will give you the same first order condition. So then I get T1 equals 4 by 3 B1 or B1 equals 3 by 4 T1, and it's proved. We can therefore claim that Bi equals 3 by 4 Ti is a Nash equilibrium. Okay, next I'm going to try the same thing with a second price common value auction. So that'll be the next video.